Glance up at the sky at night, and you're looking at one relatively tiny portion of a vast and endless expanse, the universe. It stretches for billions of light years. It's expanding, and that expansion is accelerating. It's the biggest structure we know about because, well, it is everything. But are we still destined for something else? This is Unveiled, and today we're answering the extraordinary question, what if humanity could leave the universe?
Are you a fiend for facts? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one and ring the bell for more fascinating content?
The true nature of the universe has been debated for centuries now. Past models have included geocentrism, which placed the Earth at the center of everything, and heliocentrism, in which it was the sun. Today, it's accepted that the center of the universe is much more difficult to define, but that we, neither our planet nor our star, are it. Instead, the universe is chiefly divided into two parts, the observable and the unobservable. The observable universe is everything we can see and detect from our particular position on Earth. It's more than 46 billion light years in any direction, has a diameter of about 93 billion light years, and it contains roughly 2 trillion galaxies. The unobservable universe is everything beyond that, everything we can't see and detect, because the light doesn't reach us. It's predicted, though, that the unobservable universe could be more than 20 trillion light years across, making it hundreds of times bigger than the universe we actually know about. For today's video, then, we're aiming to leave a truly incredible space. Is it even possible? The Transcension Hypothesis says that it might be, or at least it might be kind of. To understand how, we first, as with so many burgeoning social and scientific theories, have to scale back to the Fermi Paradox. We've covered the Fermi Paradox in a number of videos before now on the channel, but to recap, it's the apparent contradiction between the number of alien species we scientifically predict there to be and the number of alien species we've actually found. We predict thousands, but we've found none. A situation which, legend has it, caused the physicist Enrico Fermi to ask, "Where are all the aliens?" or words to that effect, whilst he was having lunch with his fellow scientists in 1950. The Transcension Hypothesis might finally provide an answer to Fermi's question, with the general idea being that there's a way for advanced enough alien species to transcend this universe. And that's why we haven't found them. Because they're too intelligent and efficient for this cosmos, they've changed how they relate to it, and they're simply not there anymore. At least, not from our point of view. But how? Outlined by the futurist John M. Smart, this theory turns a lot of past theories on their heads. It asks us to concentrate our energies inwards rather than outwards, to rethink what we traditionally expect a higher power to look like, and to accept that they'd not only be indistinguishable from magic, as Arthur C. Clarke's famous law says, but would actually not be distinguishable at all. In the Transcension Hypothesis, it isn't a case of advanced civilizations expanding ever outwards. And it isn't about ultra-intelligent overlords controlling the universe as if from the outside. It's not about conforming to nor completing the Kardashev scale either. Instead, it's about civilizations advancing by looking inwards and thereby changing how they view and exist inside reality. Because of this, transcension theorists often talk about inner space in place of the more traditional outer space. And an intelligent civilization is one which masters inner space most of all. So what do we mean by inner space? And how do we transcend to occupy and control it? For John M. Smart, inner space is, quote, a computationally optimal domain, achieved by what he calls stem compression. So it exists as a kind of endpoint along an ultra-efficient scale of space, time, energy, and matter, aka STEM. The idea is that in the most advanced societies and civilizations, space, time, energy, and matter should be as dense and efficient as possible. There should be no waste, or misuse, or misunderstanding. Just perfection. In the wider universe, then, against what we usually refer to as outer space, this could well amount to undetectability. According to the Transcension Hypothesis, an intelligent enough species should have honed its energy and matter to such a point that it is untraceable and impenetrable to anything else. For this reason, one interpretation is that black holes could be a final destination for intelligent enough beings. With or without black holes, though, it's an alternative way to gauge progress. Rather than seeking to expand across the stars by building megastructures and launching rockets all over the universe, a civilization hoping to transcend should actually be focusing on the subatomic world and on levels even smaller than that, getting denser and denser and going further and further down. It's about controlling data and information and mastering the tiniest bits of the universe that make everything tick. And if that really is the path to advancement, then it makes a lot of sense why we haven't encountered any alien civilizations yet. Two things could be happening. The universe could be full of low-level, basic alien groups which we haven't discovered because it's impossible for their relatively primitive technologies to bridge the vast distances of space, but also the universe could be full of high-level, advanced alien groups which we haven't discovered because it's impossible for us to see them. They exist differently to us. They've transcended. Suffice to say, in this version of reality, humankind falls firmly within the first group, the low-levelers, beaming things like radio signals into the sky without any real clear plan of cosmic action. But the Transcension Hypothesis does again serve to split the universe into two. Only this time, the labels of observable and unobservable relate to what we can see and understand, regardless of the speed of light, and what we can't. For humans, the good news is that not all is lost. In fact, it's hardly begun. And that's because, one, although our impact on the universe is growing, it's still fairly small, and two, we're now making moves to master our inner space as well. It could be then that transcension is still a path that's open for us to take. Consider the first point, that our impact on outer space is small. We've sent probes across the solar system, yes, and 2 of them have even reached interstellar space. But we're hardly a sprawling intergalactic empire with Dyson spheres around multiple stars and orbital cities circling multiple planets. In the vast totality of the universe, we're still reasonably undetectable. Not because we've chosen to be, but because we haven't yet managed to notably expand off of one planet. So now consider the second point, that we understand inner space better today than ever before. The quantum world is arguably the fastest moving and most forward-thinking field in all of modern science. The first subatomic particle, the electron, was discovered in the latter stages of the 19th century. And since then, humankind has made countless more discoveries to paint the subatomic realm in greater and greater detail. We now understand more than ever before the most fundamental building blocks of our existence, and we can control these blocks with more and more accuracy, leading some to predict us to have literal shape-shifting capabilities in the future. We're not there yet, and we might never get there specifically, but we are moving towards an optimal domain with basic matter. For a more everyday example, think of fiber optic cables, which are increasingly used to send signals across vast distances. Compared to traditional radio and communications tech, these don't necessarily require us to beam our existence out into space, and arguably can therefore be seen as another example of stem compression, of us improving and optimizing ourselves inwards. We're coming up with better, more efficient, and therefore less detectable ways to live. We're gradually working out how to manipulate matter and energy and information as dynamically and productively and powerfully as possible. So will humans ever truly transcend in this way? It's impossible to say. But we are, at least in some aspects of our civilization, moving in this direction. Perhaps one day, we'll even be able to tie all of this in with our traditionally expansionist ambitions for space. Maybe we will still move to Mars, or the asteroid belt, or even the Oort cloud and beyond. But we'll do it all in an ultra-efficient and untraceable way. We'll have left the universe as we currently see it, and we'll be existing in a new, deeper, even more meaningful realm. Meanwhile, elsewhere in this vast expanse we call the universe, there will be other, less advanced civilizations going about their daily lives. And perhaps, one day, a member of one of them will look to the sky, glance exactly but unknowingly in the direction of transcended humankind, and they'll turn to their friends with exasperation and ask, "Where are all the aliens?"
What do you think? Is there anything we missed? Let us know in the comments, check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.